In this video, we are going to continue our work with base 10 and we are going to look at subtraction. All right, let's start off with a non-standard algorithm. Let's do the equal addends algorithm. Now, the way this works, if I had 255 on a number line and I had 163 on a number line and I measured the distance between them, that would be the answer to this question. That would be the difference. The distance from this one to that one is the difference. That's the answer to this question. Now, if I take those points that I put at 255 and 163 and I move them the same amount to the right or the same amount to the left, then I have not changed the difference between them at all. I have only changed their position. The distance remains the same, so therefore the difference remains the same. That's what we're going to capitalize on this kind of problem. Now, if I can get some zeros down here in the bottom number, that is going to allow me to subtract much more easily because I can do any number minus 0 without regrouping. So you can see that here I have some regrouping, which is a little bit more difficult to do in my head. So I'm just going to move these numbers on the number line in order to make that happen. Okay, so let's start here in the ones place. What number do I need to add to 3 to make a 10, to force a 0 right there? Well, that's going to be a 7. So if I add 7 to 163, I also have to add 7 to 255 in order not to change the difference or the distance between them. Okay, now there's a little bit of a problem here. I know algebra, you know algebra. When I do negative 163, because remember minus and negative work the same, negative 163 plus 7 does not give me a 0. What I'm thinking in my mind is a positive 163 and a 7. Okay, now think about who you're doing this with. This is for like a third grader. Well, third graders don't usually know about negative numbers. So what they are doing in their head, they are grouping these together and they're actually adding 163 and 7 and then subtracting that entire sum, and that will give you the 0 that you want. So the top number, 255 plus 7, the bottom number, 163 plus 7, and then we're going to subtract that quantity. All right, so here's what we have. 262 minus 170. Since I moved both 255 and 163 7 places to the right on the number line, I did not change the distance between them, so I did not change their difference. So the answer to this subtraction problem and the answer to this subtraction problem are going to be the same. So now I've got a 0 in the ones place. I would like to get a 0 in the tens place as well. So focus on that 7. What do I need to add to 7 to make a 10? What do I need to add here so that this will become a 0? Well, 7 plus 3 is 0. But I need to remember that if I just add 3, I'm going to put a 3 right here in the ones place, which is not what I want to do. I want to leave that 0. I want to have a 3 here in the tens place. So instead of adding 3 on both numbers, I'm actually going to add 30 on both numbers. And you can see this one already has the parentheses to emphasize the fact that I'm subtracting this quantity, not actually subtracting 170 and then adding 30. Okay, 262 plus 30, that's 292. 170 plus 30, that's 200. Now this is a little bit easier to subtract because you can see I have the zeros. This one has exactly the same value as this one because I moved both numbers 30 places on the number line. I did not change their distance, which means I did not change the difference, which is the answer to this subtraction problem. And we already said that this difference and this difference were the same. So if I do this subtraction problem, the answer that I get will be the same as the answer to this subtraction problem. So 292 minus 200 is 92. I can just subtract straight down on those zeros, which means over there in my original problem, 255 minus 163 also has an answer of 92 because I added the same amount. I didn't change anything. You can also think about this as the fact that I added 7 and I subtracted 7 right here if you distribute your negative. I added 30 and I subtracted 30 if you distribute your negative. Plus 7 and minus 7 give me 0. Plus 30 and negative 30 also give me 0. So really I added 0 twice, and you guys remember 0 is what property? What property goes with 0? 0 is the additive identity. So 92 plus 0 again, still giving me 92. All right, let's look at a more standard approach. So here I have 153 and I'm subtracting 23, and we're just going to do column subtraction like we normally would. So I'm going to start in the ones place. I have 8 and I'm going to remove 3 of them. So 1, 2, 3. All right, let's see what I have left here. I have 5 remaining. So in the ones place right here, I'm going to have a 5. Okay, now let's move into the tens place. I had 5 rods, which you can see right here. I want to take away 2 of them. So 1, 2, and what I have left is 3 rods. All right, now I had 1 flat. I am not removing it, so I'm going to have 1 flat. My final answer is 135. Right? And you can see that right here in the blocks. So again, just like we talked about with addition, the blocks drive the problem. I start here with the concrete, and then I show how the abstract matches what I can already see with my eyes over here. 153 minus 23 is 135. All right, let's try this one. 203 minus 67. So we can also see here, just as a reminder, that when we added, we put both numbers. When we subtract, we only put the top number. So you can see that I have modeled here 203, which is 2 flats, 0 rods, and 3 tinies. And from that, I'm going to remove 67. Okay, so let's see what we can do here. What are you going to remember not to say? Right. You are not going to say you cannot take 7 away from 3 because that is not true. You absolutely can take 7 away from 3. It's just that you get a negative number, which our students are probably not ready to deal with. So you can point out the fact that I have 3 tinies and I need to remove 7, so I need to put some more tinies over here. Or you can notice that 3 is smaller than 7, and so you're going to have to do some regrouping. However you choose to phrase it, just do not tell them you can't take 7 away from 3. Okay, so I'm going to remove the words here so I have a little bit more space to write. All right, let's see. I need to remove 7, so I need some more tinies. So I'll take a rod. Uh-oh, I don't have any rods. I can't split a rod up into 10 tinies because there aren't any there. So I'm going to have to go over to the flats, and I'm going to have to split a flat up into 10 rods. Okay, let's start there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? You can see I have 10 rods because it takes 10 rods to make a flat. Okay, let's illustrate that over here. So what did we do? We took one of our rods and we split it apart and created 10 flats. I'm sorry, we took one of our flats and split it apart and created 10 rods. I said that backwards. Okay, which doesn't solve the problem that I need more tinies. I have 3 tinies and I need to remove 7. So now I can take away one of my rods and I can split it into 10 tinies. So let me move some of these out of the way. 1, 2, 3, 4, 5, oops, 6, 7, 8, 9, 10. Okay, so let's write over here on our word problem what happened. I had 10 rods, I took one away, and now I have 9, and I split that one into 10 tinies. But I already had 3 tinies over there. So if I look, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 tinies because the 10 that I already had combined with the three that I already had combined with the 10 that I put over there makes 13 total tinies. Okay, now we can take away 7 of them. So let's illustrate that. 1, 2, 3, 4, 5, 6, and 7. Okay, so what do I have left? 1, 2, 3, 4, 5, 6. So I have 6 tinies left, which is great because last year I remember memorizing that 13 minus 7 is 6. And that's exactly what I see with my blocks, that 13 tinies take away 7 tinies gives me 6 tinies. Okay, so now let's look at our rods. I now have 9 rods remaining. I have 5 here and 4 here. That makes 9. And I need to remove 6 of them. So 1, 2, 3, 4, 5, 6. And what I have left is 1, 2, 3, which again is perfect because I memorized a couple years ago that 9 minus 6 is 3. And I have 1 flat, and I have nothing to subtract with, so I have 1 flat remaining. So what I have illustrated with my blocks here is that 203 minus 67 is 136. Okay, so what I want you guys to do with this one is I want you to write a compare problem. And again, I just want to emphasize with compare that the top number is how many, let me do a different color so it doesn't get mixed up with my work over here. The top number is how many are in the first one. Well, that one's not writing. All right, here we go. How many are in the first one? The second number, because this is subtraction, is how many less or how many fewer. One of those words will make more sense probably depending on what your object is that you're doing. And then here is the second thing. So this may be people, this may be M&Ms, it may be dollars, it may be bees in a beehive. Like there's all sorts of things these numbers could represent. But the order has to be first is first, the thing that you're subtracting is how many fewer, and the answer that you get is the second thing. So in the last video, we practiced asking for the second thing. In this video, I want you to practice asking for the how many fewer. So first minus something equals second, and what I want you to practice asking me is how many fewer. Okay, let's also go back to this one. We're going to write a takeaway problem for this one. And remember, we talked about how you can put the unknown in any position. Well, this time I want you to practice putting the unknown in the first position. So you're going to do something minus 23 equals 135. So this could be the 23 is the how much you're losing. So maybe you ate something, maybe you lost it, maybe you gave it away, maybe it was stolen, maybe it fell on the floor. Like there's all sorts of reasons why 23 of your things are no longer there. But you have 135 things, and what you want to ask me is how many things you had at the beginning. Because remember, in a takeaway problem, time is passing. So this is how much you have at the beginning. This middle number is how much you lost, and I'm going to put lost in parentheses, in quote marks, because that could really be almost anything that just means that some of them are gone. And then this is how much you have at the end. Be careful with your verb tense on this one because time is passing. Okay, remember how we talked about addition algorithm having 2 3-digit numbers? And then we talked about how for subtraction, you have to remember that subtraction is an unknown add-in problem. So if we rearrange this problem to be an unknown add-in problem, and then I want you guys to write 2 word problems, and I want them to go with this one. The first one, I want to be a compare problem. So you're going to be asking me how much more. The second one, I want it to be a join to problem. And so you're going to, again, be asking me how much extra you got. So for a compare problem, first, how much more, second. for a join to beginning increased by end.